Okay, welcome to the second video in this series, which is about calculating magnification and answering magnification type questions. In this question, or in this video, I'm going to show you how to do a calculation where you're being asked to determine the actual magnification of the image rather than actual size as we looked at in our previous example. So this is an image from a previous OCR exam question, and this exam question, the year it was set, asked you to determine the magnification of this image of a cell here. We can still see this is a eukaryotic cell from the nucleus in the middle here. It's telling us it's 20 micrometers across from A to B, but what we're after here is the magnification of the image. So, as in our previous example, we need to start by writing out our equation. This one's a little bit easier because in this case we're trying to determine magnification, so there's no need at all to rearrange our equation. So we're using the equation that magnification equals measured size divided by actual size. We are given the actual size in this particular example. We can see here that the actual distance between A and B is 20 micrometers. All we need to do here is determine the measured size. So this is where we're going to get our ruler out again. Now if I put my ruler up to that image, up to the line between A and B, I can see that I have around 75 millimeters in between points A and B here. So my measured size is going to be 75 millimeters. Again though, we've got a problem. We have a measured size of 75 millimeters and an actual size of 20 micrometers. As we said before, we can't do that calculation unless we make the units consistent throughout. So again, we're going to have to convert the units so that they're the same. Easiest way to do that is to convert millimeters into micrometers. So here's the chart from your notebook again, and as we said before, if I want to convert from millimeters into micrometers, I'm following this arrow here, and I need to multiply by 1000. So we're going to multiply 75 millimeters by 1000 to get 75,000, and then we're going to divide by 20. So my final calculation looks like this: 75,000 divided by 20. That gives me a magnification of 3,750. Again, you want to do a final check to make sure that's plausible. If I've magnified this image by 3,750 times, that's quite a high level of magnification. However, this is now quite big. I can see it quite clearly. I can see some of the detailed internal parts and components of that cell. So we are expecting that this is a fairly large number for magnification. 3,750 seems a fairly sensible number. If we're only getting a magnification of 10, that wouldn't be plausible because that wouldn't be enough to see the detail that we see. So I'm going to show you one final type of magnification calculation that's fairly similar to this. Now you might occasionally come across calculations like this. In this particular example, we've been asked to calculate the magnification of this skin mite here, and we've not been given any set of points. In the previous examples, we were given points A or B or P and Q. We've not been provided with this in this particular instance. What we have been provided with, though, is this thing here, a scale bar. Now, scale bars are provided on images precisely for the purpose of determining the magnification. So if you see a little bar that is at the bottom or the side of a diagram and it has an actual size written on it, it's like 10 or 50 or 100 micrometers, that is there for the purposes of helping you to determine magnification. And all you're going to do is you're going to do exactly the same protocol you've done previously, but instead of measuring some part of the actual cell or structure or organism, you're going to measure this scale bar. So in this example, we are going to start off with our equation. Magnification equals measured size divided by actual size. I'll shift this diagram along so we can see it a bit more clearly. We can put our ruler up against that. And if we put our ruler here, we are able to determine that the scale bar here is around 15 or 16 millimeters long. Let's say 16. In the exam, you will normally be given a millimeters grace. So if you disagree by 1 millimeter or even 2 millimeters from the examiner, then you may well still get the mark. Let's see 16 millimeters here. So the scale bar here, it's telling us it has an actual size of 100 micrometers. Our measured length was 16 millimeters. So continuing with our calculation, we find that 16 millimeters, our measured size, divided by 100 micrometers must be equal to our calculation. And as in our previous examples, we need to convert the millimeters to micrometers by times by 1,000. That gives us 16,000 divided by 100. So our final answer is going to be determined by dividing 16,000 by 100. That should give us an answer of 160. Now that's not as high as the previous magnification, but if you look at the object we're looking at here, this is a dust mite. We can't see the structure of the individual cells. The magnification is obviously a lot less than the previous example, so 160 seems plausible. You'll note here I've also taken off the units there, which are on this example. Magnification is a unitless number. It's basically a ratio of how much bigger the image is than its actual size. So magnification has no units at all. So hopefully now you should be confident of doing any kind of magnification question. Just to summarise to finish, this is the sequence of steps that we need to go through to solve these magnification type questions. Step 1 will be writing out your equation. If you need to rearrange it, for instance if you're asked to calculate actual size, then you will need to rearrange that. Following that, you'll need to measure your diagram in millimeters. You'll then need to convert units so that your measurement and answer are in the same units. Often that will involve times them by 1,000 to convert your measurement in millimeters to micrometers, but be aware that the examiners could ask you to do something different, like converting a measurement in meters or nanometers to something else, and then finally you put your numbers into your calculator. Always do a final check as well at the end of this process to check that your value is sensible. If you determine that your cell is several meters wide, then something has gone wrong in your calculation.